Sometimes you come across an idea that works so well you just have to share it. My students and I were building this project in which we were constructing our own piston and cylinder assembly out of a piece of PVC pipe. More exactly, two pieces of PVC pipe, one that fits inside of the other. We're using this to make a large pneumatic piston assembly where we apply air pressure to the bottom and it lifts the top of the assembly up. Well, we're hoping to drive this with a standard I to P, like this Fisher Model 546. It turns out that the standard pressure range of 3 to 15 psi is more than adequate to lift up that piston, given that we have over a square inch of surface area in the piston itself, more than enough force to lift it up. The problem was air volume. It turned out that, for a couple reasons, this tube is not a perfect airtight seal against the other tube. The diameters are not perfectly matched, neither are they perfectly round. And so there's some air leakage in this piston assembly, and our I to P just cannot keep up with that demand in air. So we were left with a bit of a problem. What we needed was a device called a volume booster, which we did not have. A volume booster would take a signal from the I to P, 3 to 15 psi, and with a supply air given to it, it would boost the volume without actually changing the pressure. So 3 to 15 psi in, 3 to 15 psi out, but at a larger volume. This is the pneumatic equivalent of a voltage buffer or voltage follower in electronic circuits. The problem is I didn't have one. No one donated one to me, and so I was left with this problem. How do I solve this problem without a real volume booster? Well, one thing I do have lots of are these. These are standard Fisher air pressure regulators. You find these ubiquitously in industry. They're used in valve positioners and I to Ps all over the place. Pretty standard item. They take in an air supply right here. They output air pressure right here, and the adjustment for pressure is that screw at the top. As you turn in the screw, it compresses a spring pressing against a diaphragm inside this chamber, and the resulting force balance mechanism produces an air pressure on the bottom side of the diaphragm that matches that force. And so force in, pressure out. Very simple mechanism. But I looked at this the other day and I thought, we could actually turn this into a volume booster if we wanted to. Notice how this top assembly has a vent hole in it. If you over drill the vent hole and then tap it to receive pipe threads, you can put a fitting in here and actually apply air pressure to the top of the regulator assembly. What this does now is the air pressure forces down on that diaphragm, which generates a matching pressure underneath the diaphragm that's boosted in volume. Plus, you still have the screw adjustment to add a bias signal to it. That's exactly what we did here. We took a standard Fisher regulator, we drilled and tapped that vent hole, so now we have a 1/4 inch instrument tube fitting, and what we're doing now is we're applying pressure to the top chamber from the I to P. But this time, the I to P does not have to supply any appreciable volume. It's a small volume chamber. All it does is apply a pressure which pushes down on that diaphragm, which is now matching a pressure underneath, and this matched pressure is what now goes to our homemade piston and cylinder assembly. Same pressure as what comes out of the I to P, but much higher volume, and it works great.